We're going to look at some minimum and maximum application problems. And the first thing I want you to think about is when will a parabola have a minimum and when will a parabola have a maximum? And it has to do with the concavity of the parabola. So if we are concave up, we'll have a minimum value at our vertex, and if we're concave down, we'll have a maximum value at our vertex. So if I want to find the minimum value for this function and the x value that created it, we're looking for the vertex of this function. And this is in standard form, so we're going to use negative b over 2a to find the x value of the vertex. So the b value is negative 10, so I'm going to end up with positive 10 because this is the opposite of the b value. And I'm going to divide by 2 times 1 because the a value is 1. 10 divided by 2 is 5. So the x value that created the minimum is 5. And what is that minimum value? So I need to plug in 5 for the x's. So I would have 25 minus 10 times 5 is 50 plus 21. So I'll have negative 25 plus 21 would give me negative 4. Double checking, yep. So the minimum is negative 4 when x is 5. So now for each of these, you're going to be finding the vertex, so you could pause and then check your answers with the video. So in example 2, a ball is thrown straight upward from the ground with a velocity of 32 feet per second. Its height as a function of time is given by this function. Find its maximum height and the time that it takes to get there, and when will it be on the ground. So our parabola is going straight up, hitting its maximum, and then coming down. So we're going to find the vertex by doing negative b divided by 2a, and in this case, c is 0. So this is a and this is b. So this is negative 32 divided by negative 32, which is 1. So it takes 1 second, and when I plug in 1, it'll give me the height. So if I plug in 1, I'm still going to get negative 16, because I have negative 16 times 1 squared, plus 32 times 1. So negative 16 plus 32 is 16. So the ball goes to a height of 16 feet after 1 second. So when is it on the ground? So we haven't done a lot with this type of problem, but a parabola is symmetrical. So if it takes 1 second to go up, it will also take 1 second to come back down that same distance. So in 2 seconds, the ball is on the ground. All right, so this is a profit equation. The marketing department of a tennis racket company has determined their monthly income as a function of the number of $5 reductions in price is given by this. Find the maximum income possible and the number of $5 reductions that make it possible. This is not written in standard form, so it will be easier to analyze if I rewrite it. Negative 250x squared plus 2000x plus 60,000. And so this is going up and coming down. We're looking for, this will be our number of reductions, and this will be our income. So we're looking for how many $5 reductions give us that maximum income, and that's going to happen at our vertex. So why don't you practice finding the vertex by pausing the video. And now I'm going to show you the answer. So I'm going to do negative b divided by 2a So negative 2,000 divided by negative 500, that you should be able to do in your head, 4. So 4 $5 reductions gives the max income of, so I need to plug 4 into this function, and I'm going to do that on a calculator. So I would have 60,000 plus 2,000 times 4 minus 250 times 4 squared. So $64,000 is my maximum income. All right, and this last one is about a dolphin jumping out of the water, and the path can be modeled by this parabola. H is the height of the dolphin and D is the horizontal distance. So what is the maximum height and how far did the dolphin jump? So this question is actually asking about how far the whole horizontal distance was. But if I can find the halfway mark, which will be my vertex, then double that would be the total horizontal distance. So pause the video and try to find the vertex on your own. So now we're going to do negative b divided by 2a to get our x value of the vertex. Negative 2 divided by parentheses 2 times negative 2 is 0.5. 0.5 is my x value. So if this is 0.5 of a, it doesn't say if it's in meters, I don't know, feet or meters, then the whole thing would be 1 foot or 1 meter. Or 1 unit, we'll say, because I'm not sure if it was in feet or meters. I should have specified in the question. All right, so the maximum height would be negative 0.2 times 0.5 squared plus 2 times 0.5. 0.95. 0.95 is the height. I'm not sure if that's feet or meters, but that would be the height. I knew something looked funny. When I did my negative b over 2a, I didn't put a decimal point right there. Here's my correct negative b over 2a. It should have been after 5 units. So this number should be 5. So the total distance jumped, if this was 5 feet, is 10 feet, or 10 units. So now I'm just going to replug in that 5 as the x value of my function, because I plugged in 0.5 because I missed that decimal point. So I'm just going to replug in 5. So I should have negative 0.25 squared plus 2 times 5. So the height actually was 5 units of height. That seems a little bit more reasonable. If it's 5 feet, the dolphin's jumping out of the air 5 feet and then landing in the water, and he's jumping about a horizontal distance of 10 feet. Always pays to check your calculator and your answer.